Hey there, gang. Let's get classical. This is not a luthier-built Spanish instrument. This is a Spanish name on an American brand built in Sweden. It's our good friends at Levine. Remember, not Levin, Levine. This is their Goya line, which was actually the inspiration of an instrument distributor named Jerome Hirschman from the US, who happened to be at a German guitar show in 1952. You keeping up here? He saw the wares displayed at the Levine booth and said, "Hey, those would go over pretty well in America. Can't use that name though. You need something more Spanish." So they settled on Goya, based on the 18th and early 19th century Spanish painter and printmaker Francisco Goya. Unfortunately, the labels here don't reproduce the horrific image of Jupiter devouring his sons or the infernal meeting of a witch's Sabbath. Not enough frightening goats on the labels of 1950s import guitars. They really missed an opportunity. But Mr. Hirschman was correct. They did go over very well in America. They were probably better than the super low-cost Spanish export guitars of the time, and they're at least on par with the quality of the Tate family production. So, profitable venture. They branched out into the steel strings too, of course, and did very well with those as well. This has got a very nice European spruce top, Brazilian rosewood fretboard. Back and sides are solid European maple. Very nice. The rosette is quite Hauser inspired. So is the outline, actually. I think they probably copied a Hauser as much as they could. That's the thing. There is a Northern European tradition of classical guitar building which was distinct from what was going on in Spain. The Austrians, the Germans, they had something going on, as did the French. Different shapes for the body. The German makers used a neck dovetailed in place onto a separate body from a very early period, where the Spanish focused on the integral heel block, so the guitar is basically built around the neck. At this stage in the 1950s, though, the Spanish guitar has achieved victory. Segovia's influence has prevailed, and if you're making a classical guitar, it has to look like something out of Madrid. Even if you're like a multi-generational German guitar building family like the Hausers. So what we have here appears Spanish in most respects, but I'm thinking and hoping and wishing and praying that the neck is dovetailed on, because the owner doesn't like the action. Yes, I could make a new fretboard with a reverse taper to increase the angle. I don't want to do that. There's basically no saddle to play with. Something that bodes well is the fact that this has a typical neck block with grain that runs opposite to that of the neck, just like in your usual steel string guitar. Hooray! Yes, I can see that. The neck block seems to be sitting on top of the center reinforcement strip. How very naughty. Although it's been 70 years and it's still together, so I guess we can forgive them. It's an interesting neck. A tri-lamination with what it looks like a South American mahogany and a piece of maple down the center. Don't often see that in a classical, especially that it runs all the way up the heel. Some Levine made Goyas, of course, eventually had bolt-on necks. We ran into one of those last year, if you'll remember. This is not like those. It's also not like some that had violin-style mortise necks that insert into a pocket the same shape as the heel and are glued in place, like another guitar we ran into a couple of years ago. So I'm thinking this is pretty much a regular dovetail. Crossing fingers. Let's measure some stuff. Also, just admire this thing. Flamed maple. It's really quite nice. Action. On classical guitars, I usually think in millimeters, because that's sort of the convention. This is about 4 millimeters on the bass side, which is about 10/64, and just about 3 on the treble, which would be, about 7 to 8/64. So this is not far off of your standard classical setup. Might be a little bit high for some of today's players, but at the time it was built, this is sort of bang on. This is what you'd want. And there's still plenty of classical players who prefer an action like this or even higher, because they dig in. And when you're trying to fill like an auditorium that has no PA, and you want to hit the back seats, you really got to give it the gusto. So higher action is usually preferred. But of course there are plenty of players, like virtually every single flamenco player in the world, who want a lower action than that. And people who play jazz, for instance, or certain South American music, bossa nova stuff, they want a bit more fluidity and they want the strings closer to the frets. Sometimes that's possible. Oftentimes, though, the geometry of the instrument says no. I have to remember to ask the player if he wants to keep the butterflies when we do the string change. Other things to consider: the nut slot height on these has been set very low, such that the strings are basically sitting flat on top of the first fret. And when we lower the action, there's a good chance they're going to start buzzing here. So we may have to make a new nut or try and raise this one. I don't know what this is made of. It may be a plastic. It seems to have been shimmed at some point. The neck relief is okay. It's 12 thousandths. Classicals can require a bit more relief than a steel string because of the flexibility of these strings and their tendency to vibrate in a slightly wider path. If you're not careful and there's too little relief, you can fret a note and there can be a sort of sympathetic vibration which happens behind your fretting hand, where it'll start bouncing against the strings. So oftentimes people will make slightly more relief than we'd find in your typical Martin, for instance. If there was more relief than we've got, I might consider heat straightening the neck. That can be a bit of a risky business when we've got a laminate like this. There's always some kind of distinction that happens between the two surfaces as time goes on. I can feel that the maple has shrunk slightly. It's recessed as opposed to the mahogany. And if we start playing around too much trying to move it, you can end up with yawning cracks along the laminate line and that sort of thing, especially if you really try to push the neck backwards. So I'm going to leave this alone. These tuners are exceptionally dry and gritty feeling, so I'm just going to put a little bit of light machine oil where the posts enter the upright portions. Maybe a little bit on the gear itself. It doesn't take much. Yes, that feels better. These strings were installed by someone who knows what they're doing, which is good to see. No elaborate knots. So I'm heating up the fingerboard extension like I normally do, using my sealing iron. That's what you search for. This one was made by a company called Hanger 9. I'm not sure they're still producing this thing or not. However, if you search for sealing iron, as in sealing stuff, it's used in various manufacturing processes, and also I think model making for heat shrinking various stuff. Yes, you could use a full-size household iron. That would be fine. I did it for years and it works. You just have to be careful that you're not exposing the top to too much heat and bubbling the lacquer or something like that. So you have to be able to control the amount of heat. This one has a rheostat. I'm not sure how closely it relates to the numbers that are written on the dial, but I found one that seems to work. It heats things up and doesn't make the fingerboard turn into a cinder. If it's too hot, you'll notice that you get a whole lot of rosewood resin bubbling out if you're doing a Brazilian board like this. So, it's got to be an even heat. You want it to heat on the slower side so that it penetrates all the way through to the glue joint. And by resting it directly on the frets here, I find that it transfers enough heat. There are also other kinds. Stuart McDonald makes a aluminum block which has cutouts in it where each of the frets are. You heat that up in an oven, place it onto the board, and it sits directly on the wood, which may or may not be an issue in the case of frets that have been, say, epoxied in place. I'm fairly certain they weren't using epoxy to put these frets in, so I feel safe. On a wide board like this, I might have to move it from side to side. And when removing the fingerboard extension or loosening it, you want to work all the way to the very end of the joint here. But try not to go too much farther than that, because it can be difficult to re-glue those parts. Other thing to be mindful of is when you're removing a board that has been bound in celluloid plastic and you use too high a temperature, why, that thing could actually go on fire. Or at least melt, or discolor, or do any number of things you don't want it to do. So again, a gentle heat. It's probably going to take about 15 minutes for this to get warm enough to really release the glue. Other people will use a heat lamp for this, which is the kind of thing they use in restaurants to maintain food temperature. I've never owned one, so I've never used it. But again, the same rules apply. You'd want to find a way of protecting the finish of the instrument using some kind of aluminum baffle or something to insulate that. I use a thin, flexible palette knife to get into the joint between fingerboard and soundboard. I usually start at the body end of things, because oftentimes there is a little bit of a gap here. When the neck is seated into position, sometimes the binding will shrink back slightly as well, leaving a little space here. It can be easier to get in at this side. To remove something like this, I think you want a wider knife rather than a skinny one, because it sort of registers against a larger portion of the surface and is less likely to dip into sort of regional problems. It stays flat. I use a thin plastic sheet on the top which protects it, and because there's a certain amount of back and forth rubbing which can cause marks on the surface if you're not careful, and this just sort of protects things a bit more. This is a hide glue joint. It's going to be kind of crispy, and it feels different from an aliphatic glue like Titebond, yellow carpenter's glue, white glue, which are very much more rubbery and sticky. This is going to basically crack open. Do you use water for this? I do not. I don't like the idea of putting water on the finish if I can at all help it, because it can migrate in there and cause problems. The heat is usually enough for this. One thing to consider is that there's usually a difference in grain direction from one side of the top to the other, and you kind of want to read that and push your knife in the direction of the grain rather than against it. The analogies being like the hairs on the dog's back. If you pet it in the wrong direction, it's all going to tear up. So, you know, we find the way it wants to go and then go that way, with the blade held, in my case, at an angle. It doesn't butt directly in usually. It kind of slices across the fibers. And no matter what you do, there's usually, especially in a hide glue joint, a little bit of soundboard wood that's going to come up with the fingerboard extension. With hide glue, the two surfaces contract together so firmly when the glue is drying that there's really no space between them. It's like almost a molecular level kind of closeness that develops between the two parts if they were made correctly. So, you know, there's going to be a little bit of skim of wood, hopefully not very much. At this point the frets are still hot, so I'll go ahead and remove the 15th fret. Marking its base side for future reference because I'm going to reinstall it. I need to drill some access holes down into the pocket of the dovetail, assuming there is a dovetail. I don't know exactly where that's going to be in this model, so I'm going to make sort of an educated guess and be about 10 millimeters or 3/8 of an inch from either side, which is kind of standard. So this is a 1/16 of an inch drill bit, and I'm going to drill straight down, I think, to start off with, but I'm also going to be angling it in towards the center line of the heel, hoping that I'll hit the pocket that way. Usually it's pretty evident when you hit the void, the drill bit will sink right in. I'll try the other side. Now there are certain dovetails, of course, which are much thinner in relation to the Martin style dovetail, or the ones that Gibson use. Be much closer to the edge of the body, being only about 1/4 of an inch long versus 5/8. Well, I'm going to continue with this route and see what happens. There's so little resistance and so little dust that I'm feeling kind of optimistic. That felt good. Just as an aside, I thought I might want to take a measurement of this body. And it is a full 15 inches across the lower bout, which is about 382 millimeters. That's wider than your average classical guitar. Some makers have gone that big, but they're definitely not the rule. They're more the exception. So even for a full-size concert classical, this is more akin to, well, it's a O size body is what it is. So that's interesting. It's bigger than you'd expect it to be. I'm going to put it in the neck removal jig here. Don't ask me for plans. Designing and building your own jigs, if you want to do guitar repair, is a fundamental part of the craft. You can take inspiration from commercially available ones, maybe design something that better fits your working style, but you know, this is part and parcel with the whole thing. Main thing, of course, is that the areas that contact the instrument should be padded. In my case with cork, could be leather, could be some kind of soft urethane that isn't going to damage the surface and is going to keep you from crushing things too much. Here's the point in the proceedings where I mentioned that I get these foam cutters from hotwirefoamfactory.com. Not a sponsor, but I like them. Company in California. They've recently started making luthier specific kits for this procedure. Yes, you can buy extremely inexpensive Chinese-made foam cutters on Amazon and other places, and they will work. In my experience, they have a thicker barrel diameter, and they run much hotter than these. So the people I've seen use them usually end up with quite a bit of scorching. Like it'll be black in there. I've been using these for several years now. They've done very well for themselves. If you're gentle, and I've mentioned this before, when you pull them out of the hole, you'll probably want to use a pair of pliers on the shaft itself when you're pulling them out so that you don't separate them from the handle part of the unit. Personally, I don't use the adjustable rheostat with these. I just plug them directly into the wall with the Crafter's power supply, the AC adapter, and that seems to run at the right temperature. Oftentimes it'll only take 10 minutes or so for things to warm up to the point where the neck will come free. As always, there can be differences, depending on the manufacturer and how tightly the dovetails were fit, and how much glue was used in various areas. It could take multiple heatings, and I actually don't use them with water most of the time. I'll just use the dry heat. Periodically, as things start to heat up, I'll give it a bit of a wiggle. I can already feel this starting to loosen. It's only been 3 minutes. But don't force it, let the heat soak in. Eventually you'll start to feel it on the outside of the heel and in the area around the body joint here. Also, you can feel it on the inside of the neck block. I'll also apply a little bit of upwards pressure on the end of the heel with the screw here. The heel itself is protected with a piece of, in this case, ultra-high molecular weight plastic. Could be plexiglass or something similar, just so that you're not putting a big dent into it. Things will start to feel tighter as soon as you've done that. Won't be as much wiggle. That's because you've taken up the slack. But shortly it'll get loose again. And eventually you'll note that there'll be separation between the underside of the fretboard and the body along either side there as it gets pushed up from the pocket. Something to watch out for, especially in cases like this where I don't know where the dovetail really is in there. It's possible that I have speared through the area of the neck block and into the end of the dovetail itself. So these could be acting as pins holding the joint together while I try to loosen it. Usually you can feel if that happens. But at a certain point, after about 10 minutes, I'll likely remove these and then start wiggling without the probes in the joint. Some wiggle has reappeared, along with some sort of creaky, crackly sounds. There's the sound of wood cracking, which is something we don't want to hear, but there's also the sound of crispy old hide glue giving way, which is kind of like kettle-cooked potato chips or something. Separation is occurring here. You can see that now the heel is about a 1/16 of an inch above the surface of the soundboard. You can see light through there as well. Usually about 1/8 of an inch is what's going to be required for these two parts to come apart. I'm going to turn these off and pull them out. That came out really cleanly. And now, got a bit more wiggle, apply a little more upwards pressure. Gentle rocking. Where you're dealing with slender things that are fitting together tightly, you don't want to crack one or the other of them. It's possible to break the neck block or split off portions of the dovetail. There we go. So this is a much narrower tail than we would normally find in a martin. You can see just how far off I was with those holes, but there was sufficient heat transferred into the neck block to soften the glue and make this thing work. And down at the base you can see it just came through at the very tail end of the pocket. And for future reference, fellow repair people, the dovetail pocket is approximately 12.5 millimeters, half an inch deep, and at its widest it is about 28 millimeters wide, which would be 1.1 inches. I'll clean up the underside of the fingerboard extension. Then it's on to the actual changing of the neck angle by pulling sandpaper through the joint. This removes more material at the end of the heel than up at the soundboard edge and tips the neck back. This is a process that can take a little while, but you have to sort of be careful and keep measuring and making sure that things are moving in the right directions. I'm checking with a straight edge held on the tops of the frets to see where it lines up with the front edge of the bridge. I don't want it too high because the action is going to be higher than usual, and so I'm hitting for a place about 1 millimeter below the top surface. The fingerboard gets pretty slender as it meets the sound hole. It's tapered, and so I will definitely need a shim to take up some of this extra fall away. So I'm planing an angle into that as well. I glued it in place under the extension, and now I'll carefully trim back the edges and carve away the portion that's radiused for the sound hole. I'll darken down the light-colored wood. Having thickened the dovetail cheeks with some veneer and subsequently filed and sanded most of that off so that it's a really good fit in the pocket, and glue the whole thing together. This player wants a pickup installed. We're going to go with the K&K. You've seen me put those into various guitars before, and they work well for virtually everything. There's one thing about this instrument, though, that's going to switch up the install a little bit. We'll have a look inside. Here I'm putting a couple of pieces of tape across the bridge to show where the ends of the saddle lie. The inside doesn't have very many surprises. It's actually kind of rudimentary. The braces are low. They're unshaped. They're basically square in section. 7-fan strut pattern with the usual angled cutoffs at the bottom. Here it is with the lights off, showing the tape around the bridge. So this is good. The real estate around the strings is mostly free, with the exception of the central brace. I'll drill the end pin hole and install the jack. Here's the thing. I find that when we install the K&K in an instrument without a bridge pad, and even more so in a nylon string instrument, the sound tends to be less acoustic than we want. And I found after some experimentation that it really needs a little bit of extra mass or thickness or something to function the way I want it to function. I think the bridge pad acts almost like a filter for some frequencies, which are sort of designed into the K&K. So in this case I've made up some thin maple pads. It's about 60 thousandths thick, about 1.4 millimeters. And that should give us what we want. Now I've gone ahead and I've measured where I want the dots to go and pre-glued them to the pads. Without bridge pin holes it can be tricky to glue the dots in and be precise. I mean, I can do it with a mirror inside the instrument and a little aluminum arm. I sort of double stick tape the dots and get the glue on and get them where I want them. But in this case all I really need is a magnet at the front edge of the bridge, which will act as sort of a positioning gauge, and I want to butt up the side of the pad against the brace that's in there, and that'll get us where we want to be. The frets don't ever appear to have been re-crowned at the factory. They're kind of uneven. This is a case of that really old, really tiny fret wire again. It's about 70 thousandths wide by about, average height's around 23 thousandths. Nothing you can do to dress this stuff. The other thing is it's really soft. I can tell when I was trying to recrown some areas. This is modern fret wire, nickel silver fret wire is 18% nickel. I'm thinking this is the old stuff, which is 12. Okay for nylon instruments, but even then it tends to groove out. This being a Levine product, I've come to expect loose brace ends. Always. So I made a new bone nut in the usual fashion. A new bone saddle for the setup. The action is now 7/64ths on the bass side, 5 on the treble, which would be considered low for a classical setup. The string height above the soundboard is about 11.5 millimeters, which is pretty standard for a classical guitar. Flamencos can be slightly lower than that, but this tends to be about the right height. More than half an inch or 12.5 millimeters would be considered too tall. And here's the completed new nut. That looks right at home. These strings are extremely new. They're still stretching. They've only been on here for about 45 minutes, so this is likely to go out of tune as I play, but you'll get the gist.